Hello. So today we're going to talk about section 5b, and it is Pearson's correlation coefficient. So Pearson's correlation coefficient tells you how correlated two variables are. And you can see the formula for Pearson's correlation coefficient is right here. Don't get stressed about the math symbols here. That E, if you recall, is sum, and then it's x minus the x bar, where the bar is above it, means the mean. So it's your data value minus the mean times the y data value minus the mean. And then it's all divided by, excuse me, the square root of the sum of your x minus x mean, like your means, squared, times the sum of your y minus y means squared. And we will go through a problem to truly understand how to do that by hand. I will also post on my website how to use your graphing calculator to find the R value as well. So please be on the lookout for that too. So when we get more specific with correlation and our R value, the R value actually tells you how you can best describe that. So notice that when R is 1, look at that graph. Every single one of those points are forming a straight line. When R is -1, all of those points are forming a straight line. And then you can look through and see the range in which your R value has to be, and then how you would describe it. So for example, if I fell in the 0.87 to the 0.95, I would label that as a strong positive. If I fell between -0.5 and -0.1, I would label that as a weak negative. So those are just ways for you to describe it when asked. So let's look at a problem. So we have the Department of Road Safety wants to know if there is an association between the average speed and the age of the driver. And the results are in the scatter diagram, so you can see just by the diagram that it's pretty scattered, and it has found our R value. And our R value, it says, is 0.025, and it says to describe the association. So if we look back on our chart, 0.027 falls in the weak positive. So 0.027, actually, hold on, let me see where that decimal was again. Oh yeah, it's not even that. It's less than 1. That's my fault, sorry. I was not paying attention. So it is no correlation, whoops, because it is less than 0.1. So we would say that there is no correlation there. Let's look at another problem. Okay, so here is the Department of International Commerce, and it's comparing the size of a company with the earnings of it. And it found that our R value is 0.556. So 0.556, if we were to look at this chart, 0.556 falls in that category, which means we would call it a moderate positive correlation. So if this was a test question, you would just write moderate positive correlation. And that's all it's asking for. Okay, so let's actually now do an entire problem, and let's draw the scatter diagram and find the correlation coefficient. I'm going to see if I can copy this, and I'm going to actually paste it into let's see if it'll paste the picture. Doesn't look like it. Yeah, okay, so I'm going to just write what the table said. So A, B, C, D, E, the chemical, the quantity of the chemical was 2, 5, 6, 3, and 9. And the number of surviving beetles is 11, 6, 4, 6, and 3. So part A says to draw a scatter diagram. So if we were to draw a diagram, I actually might draw it over here. So this is our X and Y axis. 1, 3, 5, 7, 9. And then 1, 3, 5, 7, 9, and 11. Okay, so this is our chemical, and this is our beetle. So all you're doing is plotting the points. So 2, 11 would be right there. 5, 6, and this is going to have to bear with me. It's going to be somewhat okay, but not perfect. 5, 6, 6, 4, 3, 6. It's right there. And then 9 and 3. So there's our scatter plot, and you can tell it's got a negative correlation, but we're not really sure how strong of a correlation that is. So because of that, we need to find our correlation coefficient. Now with this one, I'm going to just use the graphing calculator, and like I said, go to my website and look at how to do it in the graphing calculator. You'll have to put the table in and make sure you have your diagnostics on, and then when you run your linreg, you will get an R value, and it'll tell you your R value is roughly rounded 3 sig fig 0.859. And when we go back and look at that chart, so if I go back and look at our chart here, we're going to see that 0.859 is going to be a moderate negative correlation. So we can say this is a moderate negative correlation. Okay, so let's look at another problem here. So our next problem, we have, here is teachers asking 5 students how much time they spent preparing for their speech, and then you can see the grades that they received. Whoops. Okay, so those are the grades that we received, and I am going to take that information and transfer it here so that I have more space to write. So they got student A, B, C, D, and E. Those are just the students. Student A spent 5 hours, 4.5 hours, 7 hours, 1 hour, and 3 hours. And then student A got a 95%. Student B got an 80%, a 90%, a 65%, and a 75%. So let's now take this information, and I'm not going to draw, it is asking us to draw a scatter diagram. All you guys have to do is draw your X and Y axis, label it, and then plot your points. I'm going to move to actually finding Pearson's correlation coefficient. So if you recall, our R value is equal to the sum of your X minus your X mean, let's see here, times the Y minus Y mean, divided by the square root of the sum of X minus X mean squared times the sum of Y minus Y mean squared. So we need to know our X values, we need to know our Y values, we need to know our mean, we need to be able to subtract them and square them. So what I end up doing when I'm doing this is I do a table of values. So I have my X values, I have my Y values, I need the x minus x mean, and I'm just going to call that column A. And then I need the y minus y mean, and I'm going to call that B, because eventually for the top part of the equation, if you guys recall, we need to multiply them together. So then I'm going to have a column of A times B, and then I need to do x minus x mean squared and y minus y mean squared. And what I do is I make this big table. So this is just a big table, and it helps me organize. This is not a pretty table, but we're just going to go with it. Helps me organize it. So my x values are 5, 4.5, 7, 1, and 3. My y values are 95, 80, 90, 65, and 75. And the first thing I do is I find my total of the x and y. So I add my x's together, and I get 20.5. And when I add my y's together, I get 405. And the reason I do that is because we have to find our mean. So then I divide those by 5 because there's 5 of them. So our mean of our x is 4.1, and the mean of our y is 81 when I do that. Okay, so then my next column is I'm going to take my x, each of my x values, and I'm going to subtract my mean from each of them. So 5 minus 4.1 is going to give me 0.9. And then when I do 4.5 minus 4.1, I get 0.4. And then I get 2.9. And then I get negative 3.1. And then I get negative 1.1. And then what we do for the next column, I'm going to take my y values, so all of these y values here, and we're going to subtract our mean of y, which is 81. So 95 minus 81 is 14. Change my marker here. 80 minus 81 is negative 1, and then we have 9, and then negative 16, and negative 6. Okay, then that A times B. So that's why I label our A and our B, so that I don't have to write it so much. So I'm going to take the numbers in the A times the B. So I'm taking 0.9 times 14, and I get 12.6. Whoops. And then I take the next one, 0.4 times negative 1 is negative 0.4, and then 26.1, 49.6, and 6.6. So I'm multiplying A times B. Now I'm going to take my A, my column A. So we're going to take this column right here, and we need to square it. So 0.9 squared is 0.81. 0.4 squared is 0.16. And then I keep doing it for all of these. And I get 8.41 when I square 2.9. And then I get 9.61. And then I get 1.21. And I'm going to need the sum of that. So I'm going to add this whole column together. When I add the whole column together, I get 20.2. Okay, so then what I'm going to do is I'm going to do the same thing with my B column. So we're going to take these numbers here and square them. So I get 196 because 14 squared is 196. And then 9 squared is 81. 16 is 256. And then 36. And then we add this row together and you get 570. Okay, lots of work to get to this one answer. So, why is that helpful to us? Okay, well, I forgot to add. We need to add our A times B column. So I'm going to add this row as well, and that's going to give me 94.5. I forgot to do that sum. Okay, so these numbers here, right here, my sum numbers, are going to be the numbers that we're going to use. If you think about our R, let's rewrite our formula. Our R is our sum of our x minus x mean times y minus y mean. And that's really our blue number, that 94.5, that's what that top is. And then the bottom is the sum of our x minus x mean squared, so that's our red number, times the sum of our y minus y mean squared, which is our green number. So this right here is your blue number, this right here is your red number, and this right here is your green number. So those three numbers are the three numbers you need to be able to find your R value. So let's now plug those in. I'm going to have R is equal to 94.5 over the square root, don't forget the square root, of your 20.2 times 570. And when you plug that into your calculator, you get about 0.881. So your R value is roughly 0.881. And 0.881, if we go back to our table, 0.881 falls right here. So we're going to say that this is a strong positive correlation. So there is a strong positive correlation between your amount of time you spent on your speech and the